The remainder theorem gives us an alternative strategy for evaluating functions at a given value of x. In this example, we're going to use the function f of x equals x cubed minus 4x squared plus 5x plus 3, and we're going to evaluate that at the point x is equal to 2. Now, we could go through the hard work arithmetic of substituting 2 into each one of those values for x. Now, that wouldn't be too bad for this example because this is not that large of a polynomial. It only has 4 terms. The highest power of x only goes up to 3. So we're not really concerned with our ability to substitute into that function if we need to. But it's good to know that the remainder theorem offers us an alternative if we wanted to use it instead of going through the trouble of evaluating a particular x. So instead of diving right in with x is equal to 2, we're instead going to say, let's do some synthetic division. And the remainder says that if I do my synthetic division with the factor x minus 2, that the remainder is going to be whatever I would normally get as f of 2. So synthetic division with the 2, we have our coefficients of 1, -4, 5, and 3. As we always do, we'll drop down our first coefficient, multiply to create our next one, and then add down. Multiply to create our next one, and then add down. Multiply to create our next one, and then add down. Because this polynomial was cube, square, x constant, we know that we're going to go square, x, constant, and then our remainder. So because 5 was our remainder, that tells us that if I was to directly evaluate f is equal to 2, my remainder would be 5. Thought about a little bit of a different way, using our classic dividend divisor quotient approach. We know then that x cubed minus 4x squared plus 5x plus 3, our original dividend, is equal to our divisor, which was x minus 2, times our quotient, which we get from right here, x squared minus 2x plus 1, plus our separate remainder. Now, this is not a direct consequence of the remainder theorem. That's a direct consequence of understanding division. This is the real point that we were interested in. But despite the fact that that remainder is 5, that tells us that we can rewrite this polynomial using 5 as the remainder, even though it is also the value when I wanted to evaluate the function at f is 2.